Hi, we're back for the third part of our Friday session. And this is from our practical example, the revenue function, which we determined by integration, given the first derivative function. When the revenue function is 300x minus 0.1x squared plus 100. The first derivative was 300 minus 0.2x. When we set that equal to 0, we found x max equals 1500. We took the second derivative and found out that 1500 was at a maximum point. We then took the revenue at 1500 was 225, 100. So I'm going to draw two graphs. One is the revenue function versus x, and one is the derivative versus x. And let's see if we can make some heads or tails of this. Notice this is the maximum point. This is 1500 times 225, 100. These are 100,000, 200,000, 300,000. These are just what they say. So here's your curve. Oh, not going to get that. my
The wall ate the marker.
Right. The
marker
marker's in a black hole. And a black marker's in a black hole. That's good. Okay. So, and this is the derivative function. And no, well, what is the derivative function? Well, it's a straight line. Right? It's 300 minus 0.2x. And it's going to start at 300. And it's going to go through 1500. Now notice, when x equals 1500, r prime of x equals 0. Amazing, that's how we found it. We said r prime of x equals 0, and we found x equals 1500. So this is the graph of your derivative, and this is the graph of your function. Notice your function is a quadratic. Your derivative is an inverse straight line. And that's how you look at that graphically. And of course, this should cross the x-axis at the critical point, at the maximum point. And here is the maximum point over here. All right. Now let's do the you-do problem that I gave you. And once again, this is one you probably want to check. I'm going to have to get another, I don't think this, let's try this one. If not, I might have to enter my supply. So you do, this is good. The you do problem was f prime of x is 3 over x to the fourth minus 10 over the fifth root of x to the fourth. Now doing this the way we did this before, we're going to rewrite this. 3x to the minus 4. But this is 10 over x to the 4/5. So I'm going to rewrite this again. 3x to the minus 4 minus 10 x to the minus 4/5. So now we're going to set it up as an integral. Let's erase this. If you didn't get the graph, you can always run it again. So let's, this is df dx. Multiply out by dx. And I'm not going to bomb it, I'm going to distribute it as I multiply. And the integral signs. So, here you have a equals 3, n equal minus 4. Here you have a equals 10, n equal minus 4/5. So let's apply our rule, our power rule of integration. F is going to be equal to 3 x minus 4 plus 1 minus 4 plus 1 minus 10x minus 4/5 plus 1. That would be 5/5. I'm just going to put it down as 5/5 minus 4/5 plus 1, which is 5/5 plus c. All right, so f becomes 3 x to the minus 3 divided by minus 3. All right, minus 10 x to the what? 1/5 divided by 1/5 plus c. Now, when we multiply 10 times 1/5 in the denominator, I have to flip it. So f of x is going to be equal to 3. 3 divided by minus 3, that's going to be minus 1. This is going to be minus 50. X to the 1/5 plus c. Now, this is not a practical problem, so I don't have to know how to do it. So this is my answer. Now we want to check it. Take the derivative. That's going to be minus 3 times minus it's going to be 3. X to the minus 3 minus 4. Minus 1/5 of 50 is 10. X to the 1/5 minus 1, right? So it's 1/5 minus 5/5. It's going to be minus 4/5 plus no c, 0. So let's see, what was my original problem? Well, when I took it down here, 3x to the minus 4th minus 10x to the minus 4/5. It checks. So this is the right answer. So this time I didn't make a mistake when I did it, and it checks out to be the right answer. And that ends our section 12.2, and we're going to move into section 12.1, and we're going to move into section 12.2, which is the chain rule for integration. I can hear the groans. All right. Figured, oh, how can there ever be another chain rule? Okay. So we're going to be section 12.2, the chain rule of integration. And I know it's indefinite, but it also holds for definite. So it's in general. So let's erase this stuff here. I don't need this anymore. Now there is a equation you could use for this, but I am going to do a step-by-step procedure, and then maybe by the second class in this I'll give you an equation. A lot of people have trouble using the equation, but let's see, why do we need the chain rule? Let's take example 1. So I'm given equals 3x squared plus 4 to the 5th 6x dx. Well, what I did here is I actually did not. That's not what I did. This is given this. So if we take df dx, we're going to get 3x squared, same thing, plus 4 to the 5th, 6x multiplying out by my dx, 3x squared, plus 4 to the 5th, 6x times dx I didn't want to take the integral. Now, there's no way you can apply the power rule to that. So you can't apply the ordinary power rule. Well, you say, well, hey, is there a product rule? Unfortunately, there's no product rule in integration. Now, there actually is, but that's later on, and it's kind of complex. It's really using functions, but you don't have to worry about that. For you, there's no product rule in the integration you're going to do. So how do I do this? Well, I do have a rule, and this is sort of a sunk type of rule. If f prime of u equals au to the n du, then I can say that f is going to be a u to the n plus 1 over n plus 1 plus c. Now that looks like the power rule, but in this case, u is a function of x. With some other terms, it could be two functions. So what happens here, what I have to do, my goal is to convert all terms in x and dx to terms in u and du, so I can apply this formula. So how do we do that? Well, I might not finish this today, but let's give it a whirl. I have to find out a term for u. U is usually what's inside the binomial with the power. So I'm going to let u equals 3x squared plus 4. I'm going to take the derivative of that too. Du dx equals 6x. All right. Now I have this, the u replacing that, so I'm going to need that. This doesn't do me any good. What I'm going to do is put this back up here. And I'm going to say that du dx equals 6x. I'm going to cross multiply. 6x dx equals du. I'm going to divide by 6x. I'm going to use these two terms, the ones that are in the rectangles. I'm going to use them to substitute in here. So what I'm going to get here is my integral of 3x squared plus 4 to the 5th 6x dx equals u to the 5th 6x, substitute in for dx, du divided by 6x. What happens to the 6x? Notice I got u 5th to the du.
30 seconds.
I can now use this in here, and I'll just write down the answer, and then we'll do it next time. Okay? And we'll finish that next time when we're starting out with the chain rule of integration.